Welcome back to our channel for chemistry. Today we start the functional group classification of organic compound. It is a hard topic, although it is SL, but very foundation because now we just have to learn how to name the organic compound before knowing their reaction, how they interact. Just call their names. It's complicated already. Then there are different kinds of groups of organic compound. We call it functional groups, and this one has a very distinct feature, so you need to remember the name, general formula, homologous series, and also a lot of things. You need to spend a lot of time on this part, and trust me, it's rewarding. Rewarding. Work hard here, and your organic chemistry can have a better foundation. First of all, overview of a representation of an organic compound. Organic compound can be represented by different types of formula. Empirical formula, molecular formula, structural formula, stereochemical formula, and skeletal one. Today we focus on the first two, okay? And then we have to identify different formula and convert them. One to the other, one to the other, one to the other. And for the IBDP, if you have time in the lesson time, construct the 3D model is excellent for you to understand the organic molecules. Our syllabus now, the stereochemical formula are not required now, okay, for you to draw, okay? And the functional group first is the foundation one, okay, very easy one. Saturated and unsaturated hydrogen compound, organic compound. Saturated without carbon, double bond and a carbon-carbon triple bond. Unsaturated with a CC double bond or CC triple bond. And you can name the structure by the connection. For example, halogen, okay, halogen, okay, connected with halogen CX, connected with COH, okay, hydroxyl, okay, connected with RCO, okay, we call it carbonyl, okay, carboxyl, COOH, okay, alkyl, CO, amino, NH2, amido, CONH2 or NH, okay, V, okay, ester, COOR. Phenyl is the with benzene ring. A lot of word, right? We'll talk about it one by one later. Hydroxyl, carboxyl, and ester also has the alkyl group. Okay. And one by one, the simple one is the alkane. Okay. All are CNH only. Okay. And then in the all these looks that you look at all this, we'll talk about the oxidation number of individual carbon. For this one connected with VH, and H is +1, right? So it's -3. Okay. -2 and -3. And we can talk about this alkane, this propane, okay? The oxidation number of the carbon here, so this is the average of the oxidation number of the individual carbon. So add them together divided by 3, okay? Always have a fraction. And if they have a double bond, okay, CC double bond, we call it alkane. And if they have a CC triple bond, alkene. And if they have a hydroxyl group, we call it alcohol. ROH. R is the alkyl group, okay? And if you have a COC group, okay, ROR, okay, we call it ether, ROR, okay. And if you have a RCOH, we call it aldehyde. And the name AL appears as the back, even now. Aldehyde is a RCOH. And then RCOR, we call it ketone, RCOR. Propanone, okay. Carboxylic acid, RCOH. Ester, RCOOR. Do you remember aldehyde? RCOH. Ketone, RCOR. Carboxylic acid, RCOH. Ester, RCOR. You need to remember that because they have completely different properties, okay? Chemical. Amide and amine, the difference is the one with a CO double bond is amide. Without is amine. Both has NH2. And the nitrate is a CN triple bond. Alkene is a CC triple bond and CN triple bond is a nitrate there. And then Ariane has a phenyl group, okay, it's the benzene ring, okay. Halide has a halogen somewhere, okay. Halide, okay. So you know all the thing. No, you need to more time. Maybe you can start from C number 1, C number 2, C number 3, and B file, E file, okay. And then you can work out all the things and remember it's aldehyde, ketone, carboxylic acid, ester, and you did a great job already. The compound given exam paper can be complicated, so the me file careful. So we look at recognize the functional group and then recognize the type of bond between the atoms. Okay. We have the concept we're going to polar and apolar. Okay. Like polar and apolar, not polar, polar. For the polar, they have the bond OH and NH bond, hydrogen bond, very strong. So it is a hydrogen bond for organic compound. Okay, we call it protic. Okay, for example, alcohol, carboxylic acid, amide, and amine. Okay. If on the other hand they don't have the OH or NH bond, no hydrogen bond, we call it aprotic, much weaker bonding. Okay, alkane, alkene, alkane, ethyl, aldehyde, ketone, ester, nitrate, amine, alkyl, and the protic compound is a polar. So apolic is a non-polar. So the protic compound has a higher melting and boiling point enthalpy of vaporization because they're strong hydrogen bond. Okay. But the apolic one only is weaker when the Ransdell do not dispersion form. Okay. So protic compound has stronger intermediate force than apolic compound. So as apolic compound is a weaker, so they're more volatile. Okay. If we have a container seal that you can see it's vapor easily. Okay. For the apolic one. And the polar one is so strong, for example, they will even form a dimer. For example, this carboxylic acid, they form a strong dimer, so strong that we can treat them as one molecule. The hydrogen bond is so strong, so you can have a double the molecular mass. Okay. And for the acidity alkaline, okay, we look at the group. Okay, for the carboxyl group, it will release a hydrogen ion easily, so it is acidic. pH is less than 7, pKa is less than 7. For the amine group, they are ready to absorb, accept a hydrogen ion, become NH3 plus. Okay, so it is alkaline base. Okay, pH larger than 7, pKa less than 7. Okay, other functional group are neutral in acidity. And property of the benzene ring is a good introduction for the what resonance structure, right? The low class of electron. Okay, so it has the same ring over the X-ray spectrum. Okay, of the carbon. Okay, one ring. Okay, and then this p orbits sideways orbital overlap together, forming the delocalized. And the benzene ring has two resonance structure. Okay, each carbon atom has one delocalized p electron and forming a delocalized pi bond. Okay, and the CC double bond is also delocalized. Okay, so the FH bond is a 1.5. How do you know? Because experiment. Okay, we found out the physical property. Okay, regular has gonal shape and then equal CC bond, but 1.5 bond length. Okay, the 6 bond are the same, not alternate double bond and single bond, close and far away, close and far. No. All the same. Bond order 1.5. In chemical evidence, they don't do addition reaction like the colorization of bromine and whatever. And resonance structure of other organic compound. Remember symmetry. So we need to have carboxylic acid ion without the hydrogen, and then they will be delocalized. Maybe the carboxylic acid molecule? No such thing. We need to be symmetric, so we need to be an ion. And for the benzene, of course, the benzene ring is a good, excellent example, okay, of the localized electron. And the homologous series, okay, for different things. Do you remember them? Alkane, alkane, alkene, alcohol, aldehyde, ketone, carboxylic acid, ester, amide, amine, and nitrate. Is all you need to learn. Do you remember the structure? Go back to the video and watch again. I'll find a paper to write out, okay, myself, the structural formula, okay. And they have the general formula here. And for each one, and the next one, CH2 group is added. So we got a homologous series. Very similar formula, just adding CH2 continuously. And then structural and empirical formula. Remember, structural formula is the real formula. Empirical formula is just divide them by the common factor. Okay, so first of all, recognize the structural formula. And then you think about there's any common factor. If no common factor, then empirical and structural are the same. If it has a common factor, we have to take it out. And then it becomes the empirical formula. For example, alkane is a C2MH4M plus 2O, common factor of 2. Take it out, becomes the empirical formula CmH2M plus. We can't remember this. You have to draw them out from C1, C2, C3. And you can find the pattern very quickly for everyone. It's a good training. Yeah, draw the structure out, find out the homologous series general formula. Okay. And we have concept of valence electron of organic compound is happening in the multiple choices. Okay. Valence electron is unbounded and bounded outermost shell electron add together. Later on, we have concentrate on the unbounded one for the next one. Okay. So number of valence shell electron is easy. Okay. Some of the outermost shell electron plus the net charge. So for this one, we're very complicated. Find out the valence electron from the no. So first one from this minus side, and you can see 2 carbon. Each carbon has 4 valence electron, and you can see 6 hydrogen. Each has 1, and I can see N, and you can see O. Okay, 5 and 6. So add together is 26 valence electron, bounded and unbounded. And then we concentrate on the unbounded one. Okay. Unbounded. For example, carbon and hydrogen are fully bonded, so they have low unbonded valence electron. For nitrogen, yes, 2, oxygen has 4, hydrogen has 6. So the other one is being bonded and fill the complete the octet rules. Okay. So the net negative charge of the compound is an extra number of unbonded valence electron. For example, so this one there's extra minus 1. Okay. 1 more unbonded electron. How about the other? Oxygen is 4. Okay. Yes, 1 nitrogen is 3, 2. So 2 plus 4 plus 1 so is 7. Number of unbonded valence electrons. Okay. And trend along the homology series is fairly simple. Okay, when they have more go higher, so more CH2, more CH2, more CH2, right? So more electrons, so more stronger London force. Okay, so the boiling point and melting point increase along the homology series in general. So thank you for going through with me. Okay, you see a lot of structure welcoming you. Okay. So everyone like me, okay, everyone when they learn chemistry, okay, it takes a long time for them even just to remember the name, right? Aldehyde, ketone, carboxylic acid, ester. All this term is alien to you now, but I promise you, work hard on it. You will learn it very soon. Okay, I have confidence on you. What you need to just really bring a paper out again, draw the structure out from C1 to 3 for every functional group, alkane, alkane, and alkene, okay, alcohol, everything. Just draw them out, okay, and you learn quickly. This is a quick foundation. Later on, we'll talk about the reaction. Depends on what kind of organic functional group they are, okay. So work hard on it. I promise it's rewarding. If you like our sharing, remember, share this channel with other people, okay? See you next Thursday. I love chemistry. Bye-bye.